Good morning, ladies and gentlemen. Welcome to this webinar, which is sponsored by the European Open Science Cloud, the EOSC-Nordic Baltic project, to be precise. My name is Bert Meerman. I'm from the GoFair Foundation, and it is actually my pleasure to host the webinar for the next 2 hours or so. As you may know, we have defined in EOSC-Nordic project whereby we have started to evaluate the fairness of metadata and data as published by different repositories in the Nordic and in the Baltic countries. Let me start by showing you one slide on FAIR. I'm sure some of you have seen this, but still, the term FAIR is defined as findable, accessible, interoperable, and reusable, and relates to 15 FAIR principles that data and metadata should adhere to. And not only for the human eye, but mainly for machines. I will repeat, not only for the human eye, but mainly for machines. The machine should be capable to find, to access, interpret, and reuse the data and metadata of a repository. FAIR is all about machine findability, machine actionability of data and of metadata. Let's keep that in mind. In other words, the machine has to interpret and understand what is meant. Now, I'm not going into great detail here. I'm sure Erik will say a few words about it. But if some of you are not familiar with these FAIR principles, please take time to study this in more detail. I think it's an excellent model to increase the interoperability of research data in general and for a variety of domains. So it could be energy data, could be financial data, could be COVID patient data, doesn't really matter. FAIR in that respect is completely domain agnostic. Allow me also to emphasize that, that FAIR is not the same as open and free. A data set can be offered in the market under predefined conditions. That's important, predefined conditions. And it can be for a price or for a subscription or be completely free. It doesn't really matter. And still be fair. And so making data fair does not necessarily mean that you have to give all your data away for free. I think that is important. Right, back to the assessment process. We organized last year in April a hackathon event, and from the names I can see that some of you were on that session. And we evaluated a number of repositories on the basis of their machine findability on the internet. And for the evaluation, we used a software program that could quantify the adherence to the FAIR principles and that could automatically perform these evaluation uses using the latest FAIR maturity evaluation software. And this morning, we will hear more of the evaluation process and of this evaluator by different speakers. Now, during the first initial evaluation exercise, we discovered that some repositories could not be properly evaluated due to a lack of a findable ID. And we therefore hosted a webinar step 1 last November on being findable through persistent resolvable ID. This inspired many of you to take action and to assure that most of you now have a proper ID. I think that that was an excellent result. The 2 exercises done in April and in November last year were a success insofar that a large number of repositories were evaluated, and we were able to provide a number of recommendations to repositories who wanted to improve their fairness score. However, we also noted that a large percentage did not pass the test for principle F3, as you recall. F3 is about making a proper machine recognizable split between the data and the metadata. FAIR principles want to see that the data and the metadata are published separately, and that the data points to the metadata, and in return, the metadata points to the data. And once this is the case, the evaluated test for the principle will pass. And we discussed this at length at our webinar, step number 2 on February 3. So for this morning, we have webinar step number 3. We want to concentrate on giving our audience guidance on the generic approach towards metadata. Very specific, indicating the right metadata to distinguish between a report, a document. I can hear a voice. Can you go on mute, please? Thank you. Indicating the right metadata to distinguish between a report, a document, a graph, an Excel file, or a picture. These are very important things, that you give the right object type in the metadata. And more in general, what metadata is minimally required to describe a data set? How do you define the minimal required metadata of a community in a data exchange project? How do you capture and publish these metadata elements? These are all questions that will be discussed and debated this morning. Right, let me jump to the agenda. This is the agenda. We have this morning a number of distinguished speakers. After my intro, we will start with Andreas Janssen from NEIC, giving us an overview of the FAIR assessment results in the Nordic and Baltic project. Then we have Erik Schultes from GoFair, explaining the importance and the relevance of metadata standards and the correct indication of object types, giving us also some guidance on metadata in general. After Erik, we will have a small break, roughly about 10 minutes or so. After the break, we have Robert Huber from the University of Bremen, talking about domain agnostic metadata schemas, telling us also how to evaluate metadata elements in an automated fashion by using an automated Fuji evaluator. We will talk about that. Then we have Nikola Vasiljevich with a practical approach on generic dataset metadata templates as a way to structure the process through the organization of metadata for machine workshops. We then have a Q&A session guided by Josephine Nordling from CSC, and I will close the event with a call to action for everybody. So before we pass on to the next speaker, a few house rules. First of all, make sure that your microphone is muted. Thank you very much for that. Feel free to ask questions via the chat. We will pile up these questions and address them at the separate Q&A session at the end. Be also reminded that this session is recorded and that the slides are saved on the registration page under presentation. So if you go to the registration page, you can find all the presentations of this morning. And this gives you also the opportunity to check the content at a later stage. Well, that's it in terms of the intro. Thanks very much for being with us this morning. I see a large crowd of people. And without further ado, I would like to hand over to the next speaker, which is Andreas Janssen. Thank you very much.
Thank you, Bert.
Sharing.
Yes, good morning, everyone. Let's get this slide started. Hopefully you see only one screen now. Is that correct?
Now we see your presentation or slide mode. So you should maybe switch to the
Okay, sorry.
other type of.
That's better?
Yes, that's perfect.
That's better.
Yes, good morning. Yeah, I'm here representing the EOSC-Nordic work package 4, which is about FAIR data. So for those of you who have been participating in these events previously, there will be some repetition, but I can also promise some new updates on results from our work on FAIR assessments of repositories in the Nordic and Baltic region. So the team is about 20 odd members from all across the Nordic and Baltic countries, and in addition, Bert from the GoFair Foundation. And we are now past the halfway of this project, which ends in September 2022. So our focus is about FAIR, and one of our first tasks was to estimate or to measure the FAIR uptake in the region. So so a lot of people are familiar with the acronym, and we see that the understanding and implications of FAIRifying data is quite, there's a large variation in how this is understood. So this is just to say that there's a lot more to FAIR than those four capital letters. So when we start working with this, it can get very tricky. But there are a number of things that can be done to improve repositories' FAIR score, which means that their data will be more findable, more reusable, and more accessible. And so what we have done is to look at data sets throughout our region. So what is the data set then? So typically, this is what we see when we access a data set. There's a landing page, which is formatted for humans. But embedded in this landing page are also metadata, which are readable for the machines. And it's this aspect that our study or our assessments focus on measuring. So we use a tool that Robert Huber will talk more about later, which actually goes into each data set and explores all these metadata, and to some extent the data itself. So the concept that we often like to refer to when we think about a data set is a data set as a digital or FAIR digital object. So in this illustration, which is taken from a very nice article I can recommend from Schwarman last year, shows that the core of the digital object, or the elements that represent a FAIR digital object, is a persistent identifier which references the object itself. There's a metadata that describes the content and the generic information about the digital object. A digital object may even be a collection of other digital objects. And there is a pointer to the bit sequence or the data itself, which again is stored in some repository or location online. So this is sort of an ideal scenario for a data set when we attempt to measure it. So why do we want to measure FAIR data? Why do we want to measure the fairness of data sets? This is to get an estimate of the uptake of FAIR within the region that we are focusing on. So what we did is we surveyed first the region for any repository containing research data, and we collected about well, we collected more than 100 repositories, but in the end, when we trimmed our selection criteria, we were left with about 100 repositories. Then we looked at what are the amount of repositories that actually identify individual data sets. So a requirement in order to do the evaluation is to have an identifier, or preferably a persistent identifier, but it could also be a global unique identifier, such as a URL. So after selecting that, we were left with 75 repositories. So about 1/4 of the sample doesn't support having identifiers for the research data. Then to estimate the fairness of that in the specific repository, we manually selected in somewhat random fashion about 10 or exactly 10 data sets from each of the repositories. So this left us with about 750 unique data sets or digital objects. And those...
Andreas, sorry for interrupting. There is a question or a comment in the chat box saying that your sound is a bit shaky and might improve the quality if you use a microphone. So is that possible?
Yeah, I will try to do that. Sorry
Great,
about that.
thank you.
Okay. Okay.
Yes, hopefully this is better. So we evaluated that sample of more than 750 unique identifiers. In reality, we evaluated more than 1,000 data sets because we repeated them, those that have persistent identifiers. So how sound is this approximation of only testing 10 data sets randomly chosen from a repository? A repository may contain thousands of data sets. So is that a reasonable approximation? And we tested this on 6 repositories where we could access lists of the entire repository. And we selected all of the data sets in those repositories. And so these candlestick plots show the sort of the range of the variation for one data repository. We have the full sample on the left, and then our randomly 10 selected data sets on the right. And there's a very good match, in fact, with the full sample. The boxes represent one standard deviation of those of the data sets that were measured. So there is so our conclusion from this test is that we are in fact our approximation is a good one. So this has given us confidence that the approach is good, because the challenge of testing a very large sample of repositories is that, one, it takes a lot of time, and two, we have no method to find all data sets in most of the repositories. So the goal of this exercise is not to measure, not for the sake of measuring the fairness or the uptake only, but also to enable us to provide recommendations and guidance to those repositories so that they can improve their fairness of those data sets. So we use the Fuji tool, and I won't go into detail about that. There's a reference of the article, and Robert Huber will say a little bit more about this. But that was the that is the tool that we are primarily using now to measure to assess each of the data sets, and we streamline this through scripts that were in Google Sheets that or Google Scripts that automate this to a very large extent. So this is the link to the latest evaluations of our full sample. And you can find this online or in the slides, the link there. So this, so the results are that apart from the 24% that we cannot measure, which were these those that do not have identifiers to each of the data sets, there is also still a large fraction of repositories that simply doesn't score much at all in the assessments due to the fact that they don't support machine actionable metadata. But to be fair, we do see now that the score of these data sets quite a few of the sample is improving gradually, and we are now 8%, which are over 60% score rate among those repositories that we are looking at. So we also have so this just shows the results for each of the findability, accessibility, interoperability, and reusability metrics. And we can extract quite a lot of information from the tool today. So we also look at to what extent do these data sets support the various FAIR principles, which is measured in terms of metrics. And the first one to the very left here is, in fact, the one that we are focusing on today, which is descriptive core metadata. And so this is supported by quite a few, but we do see that a lot of repositories would wisely add support to one or several of these standard generic metadata standards that we will be that others will be presenting today. We see also towards the right in the figure that there's not too many repositories that support licensing, for instance. So we are monitoring this on a regular basis. We're measuring epochs of these evaluations and looking for positive development or any development in these repositories. So these mini bars here indicate that there is some development in the FAIR assessment. And here is another view of other parameters about the persistent identifiers and the focus of today's metadata standards, the various metadata standards that are supported. So schema.org is a popular one, and probably for good reason, because it is indexed by Google and other search engines. So finally, I will just sum up. So do we see any temporal or variation or evolution or in the FAIR scores over the time that we have measured them for the last since the beginning of this year, for instance? And this plot with the blue data site enabled metadata indicates that there is a slight increasing trend. So when we started in January measuring, we measured the entire sample had an average of about 20% or 0.2, and this is now almost 0.25. But there are various aspects that are changing here. There's not only the intrinsic variation or development of fairness of individual data sets, but there is also development of the software. So if we look at the software version, so when the code or the assessment code has not changed, which is this last version 106, we see that there's very little development over the course of a month and a half approximately. So it's not easy to claim positive development or to claim that we detect a development in the FAIR uptake. So we do have to be careful about the effects here. There is also fluctuations. So we may see from one test to another that individual data sets may actually drop. So there are some features that disappear for whatever reason. But having now looked at only these last 6 weeks evaluations with exactly the same software tool, we do see that there's a very slight increase in the FAIR assessments, and this is also we see this on, if we look at individual repositories, that there are a handful of repositories that we know have done changes, and we see that those changes are add to a positive development. And this is detectable in these numbers, which I can unfortunately not go into more detail at the moment. So that's it for me, and hope the sound was not a problem.
Thank you very much, Andreas. As Bert already pointed out, we'll take most of the questions at the end. I think we'll do so in this case as well. So the next speaker we have is Dr. Eric Schultes, International Science Coordinator at the Go FAIR Foundation. He will be presenting metadata standards and digital object types as digital descriptions. So please, Eric, go ahead.
Great, thank you, Josephine, and thank you, Bert and Andreas. What I can say is these EOSC-Nordic webinars are really a pleasure, and I think they really are among the best venues I've seen where we really get down to even quantitative views on FAIR. So it's always very nice to be able to present here. It's an honor. I think you can see my screen.
Yes.
Yeah. Okay. Great. I'm going to show the slides from this non-presentation mode, just because it's sometimes easier. And of course, well, what Josephine just mentioned, the title I was asked to present on today was Metadata Standards and Digital Object Types. And I came up with kind of my own subtitle here, that FAIR digital objects, to the degree that they really are FAIR, will be self-describing digital objects, meaning that there's some information embedded there about the type of the resource that you have, and then maybe even some information about what you can do with it. And even on top of that, maybe even some semantic level understanding of the actual content. And we would say that the more FAIR the object is, the richer the description, the richer the self-description would be of that object. So that's, so this is a pretty broad topic to discuss, but I'll try and focus then on this question that Bert handed to me. We see that a lot of repositories certainly include metadata in general, but what has been noticed, and I think what Andreas has just alluded to as well, is that it's not always a very rich description of the resources there, of the object types. So oftentimes a repository will point to some data, to a data set, but we don't know if it's a graph, if it's an Excel spreadsheet, if it's a report or text, or if it's even maybe software and code. So the description is often not very descriptive for the human, And almost never is it really descriptive at the machine level. So it's very difficult to get back a deep understanding of the resource just from querying the metadata in the repository itself. And Andreas, I stole this screenshot from Andreas just a minute ago, and he's showing here that he's been testing for resource types that are specified, like for data sets and maybe other things. And I think there's a nice score here. But if we drill down and we want to look at the details, I think things often can very much be improved. And maybe another way of looking at this as well is, here's a nice repository, Zenodo. And when you do an upload of your resource there, you are given options for describing the resource type. And there's a nice drop-down menu. So there's a kind of controlled vocabulary here. But again, across different repositories, there's very little agreement right now on how to describe resource types. And this is very much at the heart of this movement to create specifications and standards around fair digital objects. So I think we can expect in the next year or two quite some agreements and processes that will lead to agreements on how we begin to talk more precisely and in a machine actionable way about resource types. But I would like to spend the rest of my presentation talking about sort of the state of the art right now. Where are we? And what are some examples of technologies and methods that can help us to start thinking through how we might want to describe data types in our own circumstances. And so I go back to the FAIR principles. And of course, metadata is all over the FAIR principles. So it's very fundamental to FAIR in general. Sorry about my ongoing cough here. But principle F3 and principle R 1.3 are particularly important for today's discussion. Bert already mentioned earlier that there's a clear, in FAIR anyways, there's a clear separation between metadata and the actual data or resource, because oftentimes you want to know about the resource before you might actually want to engage it. And so it's nice to have metadata and data, in fact, separated, computationally separated, but we still need a permanent link between them. And F3, although it seems like a very simple idea, is I think one of the big blocks right now. It's something that almost never happens at the machine actionable level in most repositories. And R 1.3 is important. It's the only principle here that actually has the word community built into it. But we realize that in very specialized scholarly domains, it's really only those experts in those domains who know enough to say something about the standards that they would like to have or that they should have operating. So what I love about R 1.3 is that it really recognizes in FAIR the role of the researchers and the scientists and the scholars in helping to define the standards that we need. Okay, so we'll come back to this in the progression here, but I want to talk about the FAIR data point as an example of these elements. And it's not to necessarily promote the FAIR data point as the technology that everyone should use. It's a nice reference implementation of FAIR, and it's a nice way to kind of get a handle on what we're trying to achieve with the FAIR principles. So here's a brief description of the FAIR data point. You can get the link here. You can even download a FAIR data point and try working with it yourself if you like. But the idea is that a FAIR data point is really just a metadata publication platform, but it's committed to linked data. So all the metadata there is machine actionable and ideally has some very rich semantics behind it. And it has a few special features that allow it to link this metadata to the resource wherever it may be, which is exactly what we want for F3. And so the FAIR data point opens the door to, or even kind of is predicated on the idea that your data can be anywhere, can be very distributed. And the FAIR data point is just this metadata platform that can link out to that data wherever it may be. So you can certainly have multiple FAIR data points pointing to the same data set, or you could have one FAIR data point pointing to multiple data sets. This is the structure of the FAIR data point. It's based on the data catalog vocabulary. And so there's a few layers of metadata here. At the highest layer, the repository layer, there's the FAIR data point itself. And it can have one or many catalogs, really data catalogs. Within a catalog, you can have one or many data sets. And within a data set, you can have one or many distributions. And we're going to talk a little bit more focused today on the distribution layer, because this is where you can really begin to describe the resource type. The distribution is that metadata layer or mechanism that allows you to describe type and do it in a machine actionable way. So what we're showing here in data set 1 is that we have a data set. On the one hand, it's represented as pure text. On the other hand, it's represented as RDF. So it's the same data, it's the same content, but the distribution is different. And so it's a media type or data format that is the distinction here. But that can be well described or self-described in the FAIR data point. So you would know exactly what's available to you when you query the FAIR data point. If we look a little bit deeper now, so if you download the FAIR data point from the source that I gave, what you will see is that it comes kind of preloaded with some very basic metadata components inside. And that's what I'm showing here. So at the repository level, there's a title, there's a description, there's a publisher, a version, etc. But all of that is richly described in RDF. And then the catalog layer has also a title, description, etc. And the data set and the distribution layer have their elements as well. And we can go through just very quickly, the FAIR data point addresses, uses controlled vocabularies and a rich knowledge representation system like RDF. So we cover principles I1 and I2 there. It also allows for, in a very minimal way now, but it sort of opens the door to arbitrarily complicated access and control procedures, authorization and authentication. Licensing is available wherever you would like it. Principle R1.2 is about provenance metadata. And so this is metadata that describes the origin of the data set or the resource. And eventually, in principle, can give you a very rich description that leads you to some level of trustworthiness or quality assessment on that. So you can really understand the provenance of your data and whether or not it will be useful for you to reuse. I3 is all about qualified semantic links, and F3 is this important, linking between the metadata and the data. So that's handled primarily in the distribution layer. But then what I really want to mention in F2, so just findability metadata, is that the FAIR data point has components for this. But if we come back to Bert's original question about, is it a graph, an Excel document, a publication, a report, that's where these things can be described primarily in the distribution layer. You can give it descriptions, and you can use elements like media type or format to get a handle on this. Just incidentally, we mentioned byte size here because we separate metadata and data, it's really nice to know a lot about that data set. For example, how big is it? Because if I want to say download it, I want to know, am I downloading something that's a megabyte in size or something that's a petabyte in size? That could be, a decision point to whether or not you actually want to begin engaging that data set. So the richer the description of the data set, the better. So let me show you what this looks like in practice. Here's a FAIR data point operating at Kampala International University. And this was set up under the Vodon project. And so here's the FAIR data point, the repository, and it has, in this case, 2 catalogs. And if I click on the migrant media report catalog, then I get to the migrant media reports, and I see that it has a data set. And that data set has a distribution, and that distribution says it's a Google document, and in fact, it has a media type that's linking out to this very semantically enabled description of the media type. And then if I click on that distribution, I get the access link, and I find out that it's a Google document. And in fact, this is just a human readable document, in itself not very fair, but now this Google document has a whole stack of metadata on top of it, including a type description, so I know what it's about. I included a couple links here on what the differences between format and distribution and media type. This can get pretty complicated. So I just want to end by saying that we've launched this concept of a metadata for machine workshop in GoFair, where we can bring you as a domain expert together with an expert in FAIR metadata to create, in a very rapid way, metadata components like vocabularies and schema that themselves are fair, kind of fulfilling these FAIR principles, but we know they're domain specific because we're working with the domain expert to create them. And then we really try to encourage the reuse. Nicola will talk in a moment about how we do this using some technology and workflows that we've created. This is Nicola's overview on a generic metadata description for data sets. And he will talk about this in detail, but note that he has a very clear distribution here. And what we can offer in a metadata for machine workshop is guidance and assistance on helping you to describe your resources, not only in a machine actionable way at the type level, but we can try to ensure that it's going to have kind of a widespread reuse elsewhere. So we really try to maximize the interoperability of things. And so here's the basic workflow. We have communities. They enter into a metadata for machine workshop with these technologies. The result is a metadata schema or a template. In this case, maybe a community specific template describing some data set for your community. That template can then be reused by researchers to create metadata instances. And then these can be linked to a FAIR data point or to your own favorite repository as you like. But we will want to register these schema coming out of the workshops at the GoFair Foundation so that we can do technical checks on the actual fairness issues, but we can also we can register and then check for the compliance to these domain relevant community standards, because it was this domain community that created them in the first place. So that would allow the foundation, when it's appropriate, to begin actually validating and certifying metadata that it is compliant with R1.3. That's been a kind of a conundrum up till now. We're implementing this now at Zone MV, kind of at scale. We're doing this now with several programs involving hundreds of individual research projects, creating CDAR templates, getting data certs to use them and put them on FAIR data points. This is the team that is doing this amazing work. And I would like to say that's it for now, and happy to take questions if there's time.
Oh, thank you, Eric. I think we actually do have a little bit of time extra here. So if we have any immediate questions for Eric, we could take them now, and then we move over to the 10-minute coffee break.
Yes, I have a question for Eric. This is Bert here. Eric, you mentioned something about CDAR. Maybe not everybody on the call would know what that is. Could you explain a little bit what this CDAR tree stands for here?
Yeah, sure. So I'll use this figure for that. So this is what you see here is a series of metadata for machine workshops, from metadata for machine workshop 7 through 12. And in each case, what we do is we work with the projects and the participants to kind of brainstorm the project assets, including data sets and software resources that they may produce. And we help them to describe in very domain relevant ways, their components. And then we work with them to create a controlled vocabulary. This is really kind of mapping their terminologies to existing vocabularies as much as possible. And so we have a vocabulary, machine actionable description that's possible because we make this vocabulary. And then CDAR comes in as a tool, and Nicola will tell us much more about this, but CDAR is a very nice tool where you can almost, in a visual way, almost like using a visual graphical user interface, you can build arbitrary metadata schema that's relevant for you. So you can build up fields, and fields can be grouped into elements, and elements can be grouped into overall templates. And you can publish these templates and you can connect them to your vocabularies. So then any researcher working in your domain can bring up this template as a web form, and that's what I'm showing at the bottom here. So it looks like just an ordinary web form. It poses questions to you, you fill in the blanks, we have drop-down menus, all of this using the controlled vocabularies that you've built. So at the end, when you fill in your metadata form, you push the save button, and that produces automatically a JSON LD machine actionable metadata description that you are using to describe, for example, your data set. And then those those metadata instances can be put anywhere you like on a fair data point. So CDAR is in fact just a very nice tool that interfaces between the controlled vocabularies, say in BioPortal, and the domain researcher who is trying to go about their daily life as a researcher. So it's a nice way to compose domain-specific, domain-relevant community standards on metadata.
Okay, thank you very much for clarifying what the CDAR tool is all about. We have one question for you in the chat. So it's by Joachim Philipson. He asks whether the fair data point is based on the DCAT model.
Yeah, indeed. So I didn't make that explicit, but you'll see it in the you'll see it in these links here, which are the specifications for the fair data point. In fact, yeah, you are looking at DCAT, and it's DCAT augmented with some vocabulary from some other sources. But this was, I think, a very nice starting point for how we wanted to think about the fair data point. But this is to say that the layers that you see here and the elements that we've included are all just sort of suggestions, and they're minimal suggestions at that. The fair data point can be arbitrarily configured as you like, if you know a little bit of RDF and Shackle.
Thank you.
Okay, thank you. Any other questions for Eric before we break for a short 10-minute coffee break? I don't see any new questions for Eric in the chat, so maybe would this be the time, Bert, to break up for coffee?
I think that's an excellent idea, and then maybe we can be back around 11 o'clock. I think with Robert. Robert is the next speaker, so I think that that would be very good. Let's do that. Let's break for about 10 minutes right now.
do you think we can start? I think the time is up in any case, so maybe we should just give it a go. I see that Robert is back, at least from his break. So the next presenter is Dr. Robert Huber from Pangaea and the Center for Marine Environmental Sciences at University of Bremen. And he will be talking about domain agnostic metadata schemas and the first FAIR approach, I guess, to the FAIR data assessments made there with the Fuji tool. So please go ahead, Robert. And would you like to share your screen or should I share mine? Great, you can share yours.
So if you can see something now, I was successful.
We can. Perfect.
Yeah, thank you for giving me the opportunity to talk about the domain agnostic metadata schemas. This is very important in the context of FAIR assessment, and therefore I've chosen this subtitle, which I did not give before my talk. It's also about how machines or FAIR assessment tools can find these metadata information. So, sorry. Okay, no. So before I start to go into the details, I would like to start with some reflections about the FAIR principle and FAIR in general. So first of all, we have to keep in mind that FAIR is for both. It's for machine as well as for human users, and it is for data and metadata. So this was explicitly expressed in the founding paper of Wilkinson et al. And so if we take this into account, it is clear that everything we do should be well readable for machines and humans. And in terms of metadata, the entry point for everything, according to the FAIR principles, is a unique or persistent identifier, which actually leads you to the metadata. So we have to take these two FAIR principles, F1 and F2, into account. And taking this PID or identifier, we need to make sure that these leads to metadata for both humans and machines. So how can we achieve this? Assuming that most persistent identifiers or ULs resolve to a human readable landing page. This is, I would say, the case for 99% of all PIDs in use in the scientific domain. So basically here you have three options. You can embed metadata in the HTML code of your landing page. Or you can do something which is recommended by the W3C consortium for scientific data, for data on the web. You can provide mechanisms which enable content negotiation. So using the protocol to deliver different formats. Or you can provide machine readable links, also again in the HTML code, according to, for example, the signposting conventions or the typed link standard, also proposed by the W3C. So this is how it looks like in practice. On the left side is an example for metadata which is embedded. In this example, I have chosen Dublin Core formatted metadata. So you can see that this is simply added to the HTML code in the head section in terms of meta HTML tags. The name is indicating the appropriate Dublin Core metadata property. An alternative is to use typed links, which you also can embed in the same place here in the head section of the HTML code. And the appropriate HTML tag is link, and you can give a relation type, which should be something like described by or alternate. Here you can then provide a link which leads to an external metadata source. So the machine would then know that it would have to follow this link to retrieve metadata. And the third option is what I mentioned before, is content negotiation. So here the client would have to send a different accept header. In this example, it is using a JSON LD. It is expecting a JSON LD response. And if your installation is supporting content negotiation, in this case, should then deliver a JSON LD file. So this is basically the most common, or these are the most common ways to do this metadata provision in a way that it serves both humans and machines. So for assessment, this is just a quick overview on the background of the Fuji tool. This is a result of the FAIR project, which is about fair data assessment. And in this task or work package I worked in, we delivered two main components. First, assessment metrics and tools which were able to assess or are used for self-assessment of research data. And these two components are addressing two priority recommendations of the this expert group report, which is displayed here. So this is the background, and the result of my work is Fuji. It is, as I said, an automatized assessment tool. It was already shown by Andreas how this looks like in practice. So Fuji is basically a web service, a REST service, which is using Open API specification. It is written in Python, using Spaka and Flask and so on. So we offer now a web service which you can install in your own machines, which can be downloaded at GitHub. It's open source. And we also have a web client, which is available at www.f-fuji.net. So, and as this slide indicates, the Fuji is based on the FAIR metrics, which are shown here on the left side of the slide. So how is Fuji looking for metadata? As I mentioned, I don't know if you see my mouse, but I'm starting here on the left side of the slide. Fuji takes a PID or an all as entry point and then tries to resolve this, or it tries to identify if it's an actionable link, which leads to a landing page. And from this landing page, it does exactly what I introduced before. It is trying to retrieve the landing page content, the HTML code or XML or whatever is delivered. And here it tries to analyze embedded metadata. Here Fuji is able to extract several formats. For example, what I've shown before, Dublin Core, and also schema.org, which is very popular in the moment. But it's also supporting simpler metadata expressions which are around, for example, Open Graph, which was introduced by Facebook, or microdata, and of course RDFA, inclusion of metadata in these HTML. Fuji is then also trying to identify signposting links in the header section or in the response head. And from there, it is following the given links to retrieve alternative or external content, and is trying to analyze this. And for example, if it is JSON LD or XML, it applies mappings and so on, and tries to identify metadata here. In the same way, Fuji is applying content negotiation to retrieve external metadata and to identify metadata content from there. So this is just an overview how this works in practice. The metadata format Fuji is able to analyze or identify are in primarily domain agnostic. So these are interdisciplinary standards which can be used to describe a variety of types and data of various disciplines. So most widely used in the moment, I think, are Dublin Core, DCAT has mentioned before, schema.org, and I put also on the list data side schema, which is a proprietary format, but it is built in if you use DOIs. And so therefore, I just put it here. So in details, a short overview on the pros and cons of these formats. First of all, the most popular is Dublin Core. It's very, very old. It was introduced by the DCMI consortium, I think more than 20 years ago. It is basically a metadata standard as well as a vocabulary. So this means for Dublin Core, there is an XML schema available, which can be used to provide XML formatted metadata. But in the first place, Dublin Core is a vocabulary which can be used to express metadata in, for example, RDF, microdata, RDFA, and XHTML. So this is quite flexible and very popular. Just some words on the protocols. I just added this for completeness. So the most natural protocol for Dublin Core is, of course, HTML is not, it's not listed here, but Open Archives Initiatives protocol here for this Dublin Core is the default metadata format. And of course, if you express Dublin Core, you can provide Sparkle interface to expose this to the public. Some pros and cons of this format is it is very well suited to embed the metadata in the landing page in the HTML. This makes it very good for serving machines as well as humans. And cons is it's very generic, so you have little options to support disciplinary specifics or extras. For example, it is very hard to link data from there. I mentioned this in the talk in February already. So schema.org is another very popular format. Let's say it is was proposed by major search engines, Google, Bing, Yahoo, and some others. And it is basically a vocabulary as well as it provides some schemas in terms of classes and properties and so on. So the metadata expressed in schema.org can be expressed in RDFA, and most commonly JSON LD is used to express. On the right place is an example how this looks like. So protocols, again, you can expose it via Sparkle interface, and I have listed here Google dataset search. This is not really serious as an interface, but schema.org is supported by Google dataset search, so you can at least use it to find datasets expressed in this with this metadata there. So it is very suitable for to embed it in the landing page, and this is also what we see very often when we use Fuji. Therefore, it is well suited for humans and machines. And really advantage of this schema.org thing is that it is provided by or was invented by major search engines. So this means search engine optimization, SEO, is already included and done if you use this. So you serve two purposes, the scientific community as well as your appearance in major search engines. A con is that it is quite difficult to validate, so you can make some errors, but yeah, on the other side, there are so many examples that it is easy to provide it. So the third format I would like to introduce, it was already mentioned before, it's DCAT, in particular version 2. This is basically data cataloging metadata vocabulary, and serves to express metadata in RDF and also JSON LD sometimes. The most natural protocol for this is Sparkle, of course. So it was dedicated, it's dedicated for providing information for data catalogs and data. It is using existing vocabularies, which is very good, for example, Dublin Core, and it is very extensible. So you can add here, of course, in RDF, scientific and disciplinary specific things, if you like, for example, what Benjamin mentioned before, links to other entities, calibration sheets, stuff like that. So this is quite flexible in this respect, and it is widely used in the open data community, which are serving governmental data. For example, the European Data Portal is using DCAT to harvest data, and it is also accepted by Google Dataset Search. So, well, as a con, it is again difficult to validate with RDF, so you can make some mistakes, but also here the community has provided a lot of examples to follow. So I think this is not too much difficulty. So these are the main agnostic standards. I hope I could help to understand them better. If you would like to play with Fuji, you can, as I mentioned before, you can download the code and install a known server, or you can use this demonstration web frontend at f-ujinet to perform your own assessments. Thank you.
Thank you very much, Robert. I think we will go straight over to the last speaker of today, which is Dr. Nikola Vasiljevic from Department for Wind Energy at the Technical University of Denmark. So please go ahead, Nikola.
So thank you very much for invitation to participate in this workshop meeting. And yeah, I'm going to present you a generic data set metadata template, which we actually start building during the last year metadata for machine workshop that we're organizing in cooperation between DIKE and GoFair. The content of this slide is basically a mix of the already existing material. One of them is actually material that we are going to use in our rapid M4M workshops, and I have to thank to my colleagues Hannah and Diba, who were contributor to the slide deck, and as well to the last week presentation and RDA meeting where John Grable helped in building the slide deck as well. So just to give you just a quick introduction to the protagonist in the slide that you will see. So we have humans represented by Robert and Anna, and the machine represented by 3M. And these are the characters that we usually use. We use basically in our material when we are teaching in rapid M4M workshops. So the idea that has been quite resonated through the presentation so far is that to comply with the FAIR standards, we really want to go from metadata and data which are only understandable by humans, typically represented by a simple HTML static landing page on the left, towards the right side of this slide, where also besides humans being able to understand, that machines are able to understand our metadata and data. And the reason why we want to do this transition is basically, I mean, to alleviate a need of humans to do tedious and relatively boring work. Let's be honest, it's not the most thrilling work to sit down and populate metadata cards. I mean, if we can instrument machines to do that for us and help us in daily work to find the data and at least like do some filtering, then we can spend most of our time doing creative work. So that's why this initial push, if it needs to happen, even if it requires quite a lot of energy, is required to help us in the long run to do our work much more efficient. Probably you heard that so many times so far. But anyways, that's what we are transitioning from the static web pages to the graph representation of our metadata, at least metadata, and in some cases also data. So to get to this point in 2 years down the road that we actually have metadata and data which are by default understandable by machines, therefore also by humans. And the level of information that we want to provide metadata about the data will depend from community to community. For some communities, handful of information, handful of fields describing metadata will be enough. In other cases, some domains and some research groups are so mature that they want much more detailed amount of information to describe the data. So creating much more rich representation. So that will be very highly dependable from a domain to domain. The way how we typically build, and usually for us, when we start with a simple spreadsheet and we start to figure out what are kind of fields that we want to fill in in order to report the metadata, but eventually we go from the form, which is on the left side, to represent it as a graph on the left side. And just going through, like we are attaching to the template certain fields, such as in this case identifier. We describe what kind of values it can have and so on. And as I said, like we need to go from the point where we have a definition of metadata fields, which are purely like strings, which are usually understood by humans, but you can always have a hectic dialogues between researchers what a specific term really mean. Towards the representation on the right side of the slide, where we basically substitute these strings with the persistent, unique, and resolvable identifier, which is basically bluntly said URLs that can resolve. And you can see how the transition goes from a title to the DC element title. And another thing is that for every field of a template, we are adding the value, which ideally we shouldn't have free text. We should avoid free text as much as possible, because giving free text, there is a plenty of possibility for errors when the metadata are entered. Of course, some of the fields of metadata cannot have control vocabularies, but we should aim for control vocabularies. And you can see here in this example, for rights or licenses and for subjects, we are, in this example, sourcing control terms from two vocabularies. Why is one in blue and another one is purple? In the blue one represents generic control vocabulary. It's a license, it's open source licenses that any domain can use. But for subjects of Dublin core field of subject, well, those are very specific to domain. And here, what I show you an example is that in wind energy domain, we have built taxonomy of research topics, for which like basically we are trying to describe the data set can be used. And another one is variables the data set contains, and this is also purposely in purple because every domain will have its own set of very specific variables and what those variables really mean. Accordingly, that's how you start basically building a metadata template. And what we usually have seen over the past few years working with the metadata templates and trying to describe the data sets from different domain is that you can generalize to the large extent the number of fields, and what will differentiate one template for one domain from another one are basically control vocabularies, which are very specific to domain. Sometimes you might have an extension of the template for the very specific purpose or specific domain, but that's basically the process. You will very soon see there is lots of overlaps, and therefore the reusability is very, very great. As we saw in the previous presentation with the DICA2 or Dublin core per se and so on. I'm just going to go very fast through some of the slides. Sometimes when you have very rich metadata templates, fields are often grouped in elements, such as, for example, when you want to describe a creator, so it has an element creator, which has a specific field such as creator name, email, persistent identifier, or creator. So it just helps you to nicely group and create much like richer metadata template. And how you build, like just a quick run through of how you suggested way of building control vocabularies is with this type of with this specific data model, which is RDF. Usually Turtle is one of the most readable formats for representation of RDF for control vocabularies. And to start easy, we always suggest using SCOS. And reasons why you can read after this. There are lots of information, more information in slides that you can check after the presentation. Similarly for metadata specs, linked data is a good approach. We saw and heard about JSON LD already in the previous presentation. So that's what we based our specs when we were building generic dataset metadata template. So jumping here, where do we start? We basically, as I said, like we have the GDMT, which can be tuned for the specific domain, and how you will see in a bit. Just to give you a quick overview, we did consider both data site and DCAT schema. And to be honest, reason why it was like appealing to us, first of all, in 2017 in wind energy community, we started building metadata template based on Dublin core, and data site actually is using almost all, if I'm correct, all the elements that Dublin core has, and then DCAT is like further extension, I would say. And what we try to do is to fuse those already existing initiatives improve them if possible, and extend them to the level that is necessary, and simplify, because at the end of the day, somebody needs to fill in those templates. And if you give them so much mandatory fields, they would say just like, no, I don't have time for that. And GDMT is very rich in that sense, has 100 fields, but will require only 13. And why we require those 13 is because if you fill in those 13, you have an instance of metadata template that you can eventually register the data site and get the DOI. Because in research, that's the current currency. It's a DOI. And if a researcher was going to spend any time filling in the templates, they want something in return. And that is, in this case, DOI. So these 13 mandatory, 100 fields are grouped in 20 elements. And unlike data site template, the GDMT is fully machine actionable. And you have an access on the CEDAR platform, which you heard already by now. And all the semantic artifacts, basically JSON, LD representation of the fields, elements, and the template itself is accessible on GitHub with some additional description. What makes GDMT machine actionable is that we actually created backend ontology or control vocabulary that enables this. And we have over 130 RDF properties, and we built quite a good number of control terms. So when our users go to fill in the template, it's more or less lots of drop-down menus that they can select. And of course, we reused all the existing RDF properties, but there are quite a number of them lacking. So that's why you have this large number of RDF properties that we created. And importantly, this whole process of deriving GDMT, it's really starting during the metadata for machine workshop last year in Denmark, go online. And we continue improving it in this year as well. And now it's basically available online. And Eric already showed you a similar slide like this. It has these typical elements. This is very much data site content with some extension, because particularly for atmospheric science, climate research, and wind energy, we are talking about very well-structured data sets in terms of spatial and temporal, and which all of the what we notice as well, what makes, as I mentioned earlier, what makes a domain specifics are variables, and we haven't seen in any of the existing templates, which are well-known, element which is corresponding to the variable which we added. And then, as Eric mentioned, to follow the DCAT setup, we have additional extension for the description of the distribution itself. And as I said, you can find everything on CEDAR and also GitHub, and you can make an instance and improve and actually specify the GDMT for your own domain. And how you do it typically, that's what we learn in the process, is that the best way for most of the domain to start tuning generic template to be domain specific is through the development of control vocabularies, which then require that you update GDMT to read those terms, those control terms, when you instantiate and create the metadata. And that's the process that we are having now in more or less in the rapid M4M workshops, is that we teach people how to build control vocabularies and how to tune this GDMT template to learn how you build machine actionable template yourself. If they're not satisfied, they can build it themselves, of course. And this is how it looks in the CEDAR OpenView. I can quickly jump, but I can do it later if there are questions. We can go into more details of how many fields and how you actually fill in those values. But everything is available online. Everything is open source, so you're absolutely free to play and try it yourself. And there is a nice video that John Grable made of this whole collaboration of how we did it with wind energy domain, the whole process, and why we made Fair Data Collective, which is basically our playground where we spend our free time building open source and free fair data tools. So there is a YouTube video describing in 3 minutes of how we build all this infrastructure. And what is very important, what I was saying to you, is that why we have control vocabularies and why we want to have things machine actionable is because ideally we want to remove humans of spending time filling in the templates. At best, they should just approve or disapprove the generated metadata which is generated by the machine. And I'm testing this idea in one of the projects that I have at DTU, which is development of RESTful API for acquisition of new European Wind Atlas microscale data for subsetting and aggregation, which will have an option that this metadata is basically immediately generated, both fused together with the data set that you'll get because you're using a lot netcdf file format, but that you have also option to decouple and have metadata publication self-sustained, in this case on the Cedar platform. There's lots of tooling that are available on Fair Data Quality. You just need to scan this QR code or just click on the link, and you will see what's there on what kind of repository you can have access to. And basically, that's quickly my presentation.
Thank you very much, Nicola. Do we have any immediate questions for Nicola? I see that we have quite lively discussion in the chat already, but most questions have been answered there. I just inserted into the chat a link to a Google Doc where you can see all the questions and answers collected so far, if you would like to go and look at those. But any additional questions? If not, I don't see any questions in the chat or any raised hands. I think we can also discuss some of the comments that have been made, see if there are any reactions to those. So at least we have one quite general comment made by Doug Anderson, and he is saying that he would be interested to see the balance between generic metadata for cross-disciplinary reusability and domain requirements for specific community-wide metadata elements. So is that something that has been thought about before in some format?
Can I answer?
Yes, Eric. Yeah, sure.
Go
ahead.
I think that's a very good question, and I think actually GBIF does it very well in the moment. I think the challenge we all have is how to provide metadata for well, as many communities as possible. So therefore, I think it is important to, of course, support domain agnostic metadata schemes, which also serve in some cases to raise your appearance and findability in search engines. But at the same time, of course, it is extremely important to provide the community with the metadata and protocols they need. And so this biodiversity data is a very good example because it has a long history of well-known and well-accepted formats like ABDC and Darwin Core and so on, which are in use for, I would say, more than 20 years now. So I think it's important to keep the balance and to maintain both branches of metadata provision. And what actually is also important is to provide both information for any target user, just assuming that you do not really know if they need this metadata or not. So this is just a thought on that.
Okay, thank you, Robert. And I guess Eric was next in line.
Hi, yeah, and this is, I think, related to what Robert was just mentioning, and it's kind of a question to him as well. I was involved in one of the early evaluator projects with Mark Wilkinson, and one thing that was a bit of a curiosity then, but I feel like I've come to understand better subsequently, is that we sort of left R 1.3 empty in our evaluator tests, because R 1.3 is asking for domain relevant community standards. And we struggled because we thought, well, how do we define domain relevant? Is there a registry of that? I mean, how do we register domains to begin with? So it was very difficult to try and understand how we might build a generic maturity indicator for that. Subsequently, you see in the evolution of metadata for machine workshops, an attempt to begin scoping what we mean by domain relevant. So we work with a domain expert to create a metadata template. And in that workshop, or let's say for the community immediately involved in that workshop, that's a perfectly useful template for them because they created it. And if we just assign a unique identifier to that workshop, to the participants of that workshop, you can think of it as a small community, and this is their domain relevant metadata standard. They may speak for a larger organization as well. In that case, the metadata template could even be more widely applicable than just the participants in that workshop. And we see examples of this. So that gives us a way to start triggering an assessment of R 1.3. It's like, oh, this workshop says this template is useful for them. If we can validate that schema again later on, then we know it's compliant to R 1.3. So I'm just wondering if this flow or this logic would fit comfortably in the Fuji approach. Could we build a kind of Fuji indicator for kind of self-described communities that claim certain metadata components as their domain relevant standard?
So actually, Fuji is trying to solve this by using lists of metadata standards which have been collected by there's a RDA group and there's also an RDA metadata catalog around. And based on this and various other sources which are also listing communities which are using these metadata, and also there are lists for data formats, Fuji is trying to identify this. And in an automatized assessment, this in the moment is done by identifying namespaces, for example, which are used in XML files Fuji detects, or for example, in Fuji you can also provide a OAI PMH interface rule. So, and there Fuji just performs a list metadata formats request to retrieve these. In the same way, it is in a newer version also dealing with other interfaces like in Sparkle or catalog service for the web and so on. So there Fuji tries just to retrieve as many namespaces as possible and tries to identify the metadata format and vocabulary and so on, and the associated community for this. So this is what we do in the moment, but of course this all relies on the controlled lists and so on, which is still a challenge. We in the moment took this from RDA, did extend it a little bit, and what we also do, we use standards which are listed by users in R3 data. So these are the things we are using, and well, it's not perfect, but in the moment I think we do not have very much different options in place.
Yeah, super. I don't know, Robert, maybe if it's possible, you could maybe supply a link to the GitHub that might be relevant for the R 1.3 elements. I don't know. Like for example, the RDA list that you're using. Is there a way that I can take a look at that? I would be very interested.
Yeah, give me a second and I'll.
Yeah, sure. Absolutely. Yeah.
Okay, thank you. In the meanwhile, Joachim wanted to comment or ask a question.
Yeah, thank you. Joachim Philipson from Stockholm University. I have a question that concerns both Eric and Robert and Nicola. I mean, even if you provide this tool, the Cedar tool or this GMDT to make your own template, if you are, like we are, dependent on service providers hosting the repository, the actual repository, they have their own metadata web forms and give little or no possibilities to customize your metadata. So, I mean, what you're saying now is, I think you're directing yourself towards host repository service providers rather than to individual users or even data curators. And I mean, we have, for example, we use Figshare as one. We have our own instance of Figshare institutional, and we have some custom metadata. But I mean, I doubt that we could upload a whole template, a web form like that, and have that as part of the custom metadata. And even if we could, the custom metadata fields will not appear in the export format. For example, if we export to DataSite or to some other standard, we use METS, for example, they will not show up in that export. We will get the custom metadata only as part of the file metadata that we can reach via an API. And this is a problem. A similar problem, and now I'm directing myself to Robert, is that even if we have tried out Fuji on different data sets, and the one that we always fails on is the second of interoperable. I think it's metadata uses semantic resources, and you should provide namespaces of known semantic resources. And for example, Dataverse, Harvard's Dataverse, they allow that once you use keywords, you can put in URLs to a semantic, an ontology and even if you try to do that, and we pick those that come from the linked open vocabularies database, even if we do that, it does not make any difference when we try to evaluate it with Fuji. And I know colleagues of mine at the Bolin climate database who have their own repository. They score get a very high score, 83% on Fuji. But this is the one that they don't know how to manage to get a better score. So, well,
may I jump in and answer the first one, Robert,
yes,
if you don't mind? About, first of
Go
all, Joachim, we at DTU, we are running an instance of Figshare as well. And in 2018, we tried to extend exactly the same problems that you're mentioning. We extended it with our specific vocabularies and specific fields for wind energy domain. And you can see it if you go to data, DTU-DK, and select wind energy domain, you will see that we have specific inputs. And you're right, when you export, you don't get anything. And then there is a question, why the heck I'm doing this if there is no point of it not going there? And we are not going towards being a repository whatsoever. I mean, Cedar is open source tool, and you can optimize the way you want. And the great thing about tooling is similar to what Robert was mentioning for his tool, is that we have API, and the whole thing is like solved. If you're going to, you can create the metadata and connect it to the Figshare. You probably need to put some in between code to do the reshaping. But to keep the metadata machine actionable instance of that, I mean, we don't have other option. That's the thing. Like I cannot wait Figshare or Zenode or whoever to improve their services so I can extend it, because I don't think that it will happen. Particularly because Figshare is private company, so they need to have a control of what's going on, and similar. So we need to reach out for other solutions. I mean, I wouldn't try using, for example, in this case, Cedar or any other third party, if a service such as Figshare is providing me what is necessary for me to achieve fairness, and I can't, time being, I don't have control of what is also shipped to data site to generate DOI as well. I might be wrong, but that's why, like for me, we have now a hybrid solution. So we still publish a lot of our data sets in DTU data, which is instance of Figshare, but we will parallel to it, we will generate machine actionable metadata, much more detailed, and ship it to Cedar using GDMT. And ideally, we should have one simple web UI user interface to do that, which, like, from that point will ship metadata needed for Figshare instance to get us the DOI, and then much more richer representation to Cedar. This is, of course, like a hybrid solution, not the most elegant, but that's what we have to work with until we see either these major players changing and being more, providing us solutions that we can customize. We are not satisfied with them, bottom line. I hope that answers your question. At least the first question.
Okay. I hope some representatives of those repositories were here to hear this. Sorry.
Yeah, and regarding Dataverse, yeah, this Philip already answered this in the chat now, but they are working on supporting controlled vocabularies. So maybe Philip can answer this directly.
Sorry, Robert, that was to me.
So Philip Concept,
Philip,
he posted something in the chat, so because he knows something about the Dataverse plans regarding controlled vocabularies. So I heard about that, and so.
Can you hear me?
Not to...
Yeah.
Can you hear me?
Yes.
Okay. Yeah. It's as Robert said, it's work in progress. The idea is to provide this for metadata fields like keywords and identifiers like ORCID, ROAR, and so on, so that one then the depositor could then choose, or first choose a controlled vocabulary, could be domain specific or general, like, for instance, contributor roles and so on, and then choose from the chosen vocabulary a suitable term, and then we would provide this also for harvesting or other negotiation, like in forms like JSON, LD, or schema.org.
But my point was that it seemed to me that is already there in Dataverse, but yet Fuji cannot find it even if I have put in.
Yeah, it's right now it's only, as you said, you can right now, for instance, in the keyword fields, you can provide a URI to control vocabulary, but it's kind of manual thing. It's not, as you say, it's not represented in the metadata export that you can provide from the Dataverse repository software. Okay. So once this controlled vocabulary support is in place, then it will also be provided as a metadata record, because now it's only a free text. It's nothing more than a free text field where you can provide a link to a controlled vocabulary, but it's not really implemented in the software as such.
Okay.
If I may, I'm just going to show you how simple this can be. I understand that. So this is GDMT template. And all I need to do is to press populate, and it will start. And all my control vocabulary, I'm just going to show you, for example, creator type. This is all sourced from the control vocabulary, which is fair, which is machine actionable, which then is, once you instantiate, it becomes accessible as a JSON LD, and there is like open APIs to access. There is simply like everything is documented, and we have a ton of those. If I go, for example, just to show you for on the level of distribution for media type, we have complete list of media type also represented as a control vocabulary. So until this becomes parts of a major platforms, just to answer again to Joachim, why did we do what we do? we need to start doing this and show to the community that it can be done. Because I think in FAIR principle paper was published in 2016, and I think we had quite a number of years discussing a philosophy about that. And now it's more about literally rolling up the sleeves and trying, instead of having long philosophical debates. I'm sorry if I'm stepping on somebody's feet. I just simply am an engineer in heart, and I prefer to fail fast instead of preparing to fail, brutally. Okay, I just show you, and you can try this already now and see it. And I will stop sharing screen.
Okay, so we still have a few questions, or do you still want to further on this discussion for a while? That's really great that we have a lot of things to discuss, and it's very lively and fun. But I think we should address some other questions in the meanwhile. We have one question from Volmar Nyberg Åkerström. Philip Kunzet has already replied to this question, but I think Andreas could also give an answer to this. The question is it realistic for repositories to monitor and address their FAIR assessment scores at this point? And what can you realistically do if you rely on a standard platform such as Figshare or external domain repositories?
Yeah, I think I need to ask Volmar to clarify that question a little further, because I don't quite understand the first part. What do you mean by monitoring FAIR assessments?
So I can clarify that. And I was thinking about, if you have a contract with a repository provider such as Figshare, and I mean, you don't really know how fair this is. Would a realistic solution be that kind of we go to your tool and look if we can find some of our data sets listed there, or kind of being part of your assessment? I mean, can we do something about it, and should we look at these scores, or is this something that you're doing for kind of a more broad strokes pulse on the Nordic states, so to speak?
Yeah, okay, then I understand you better. So yeah, the assessments that we do are, as I mentioned, they are purely as a guideline to the communities, so that they can see how they fare in terms of fairness of their data sets. I think, and this goes to the point about those of you who are using commercial providers like Figshare. I think you then, I mean, an institution which is basically a customer of Figshare should use their consumer power to demand change, and this flexibility that Nicola mentioned about integrating, allowing better integration with third-party metadata provisioning. But so what you can do in terms of going beyond your current scores, and if you are not happy with those as they are with the provider, is I can't really answer at the moment. I understand the dilemma, because you don't have direct, from what I understand, you don't have direct influence on Figshare's, in this case, metadata provisioning, but yeah, I would get into a dialogue with them and see what can be done. What we can offer, what we do offer to communities, is really a meeting where we sort of recommend what can be done if you are in your own control of those metadata. So if you're running this on a software platform which you are in control of, then it is relatively easy to make changes. So this is something that I guess we have been aware of with the providers like Figshare, but didn't really realize that it was such a big issue, that they are not flexible, to use that slightly provocative word.
Yeah, so I mean, the second part of the question was also, is this the time to do it? Because I mean, we rely on a lot of external repositories that we recommend that researchers deposit to. And I mean, we are not at all in control of those. So, I mean, is this the time of convergence and we should start pushing, or is this something that EOSC will be kind of taking care of, so to speak, and it will resolve itself?
Yeah. That is a deep question, because it's not clear what EOSC eventually will take on in terms of providing data. The stance that we have made in EOSC-Nordic is that we will try to help data providers where they are, in whatever way they make their data available. We will provide them with guidance or advice or recommendations on how they can make their data more fair, and it's really up to those communities to address that. So I simply don't have an answer to what EOSC may do in the future in terms of sort of converging. I believe personally that metadata will remain at all these various repositories, and you have to adapt or make those metadata more fair yourself. That's at least the approach or assumption that we have made in most of our cases. So sorry if that didn't quite.
Thank you. I think we can take one more question, and we have an excellent one also from Volmar. So I think it's for Eric. Where should I turn to get an overview of metadata for machine workshops and standardization initiatives being conducted in the Nordic region? And how could I get involved in promoting and enabling fully fair practices?
Sure. So from the GoFair point of view, you can learn more about metadata from machine workshops from the links in my slides, but I can also forward a couple of links in the chat here. And as far as a more overall standardization, I think in GoFair, we really try to just push kind of fast track implementations, realizing that things can sometimes be very agile at the domain level and at the project level, or where people are really implementing. So and I think part of the equation in all cases is that there's some need for standardization on one hand. On the other hand, there's also the equally important need for that freedom to operate at the domain level. And I think that's what we're struggling to try and figure out here. So the metadata for machine workshop, I would say, is a venue, is a format that embraces the freedom to operate, and it leaves the generic elements to the fair metadata expert. So if you take a M4M workshop, you have your freedom to operate. You're supposed to create components that are fit for your purpose, but without having to think too deeply about it, we will guarantee a certain level of interoperability and fairness. And these are all these things are debatable in a workshop, but if you're willing to move quickly, we can come to you already with some well thought out, well reused solutions. So we're trying to strike that balance in an M4M. For repositories that have well developed metadata, it's maybe a different story. We have to think about maybe some more infrastructure type changes, but for most practicing scientists, an M4M, I think, it's a really excellent solution to move forward.
Okay, thank you, Eric. I think we have used up our time already, so thank you for a lively discussion. It was really interesting. So now over to Bert for some final remarks and closing.
Yes, thank you very much. I can see that it's almost lunchtime, so that's good. Thanks, everybody. And in particular, thanks, of course, to all the speakers. I trust that all of you have seen enough information to understand the relevance and the importance of having your repositories being findable, accessible, interoperable, and reusable. and that we all understand much better the importance of rich metadata and also the controlled vocabularies, which we have talked about in the last sessions. I would suggest that either we take action ourselves or we present these requirements in the organizations that we represent, so that we will continue on this path of, let's say, the increase of the FAIR uptake. If you need any help in that work, we are more than happy to assist you and to help you with that. And with that, I would like to close the session. Thank you again very much for being with us, and enjoy your lunch.